here's a function and it exhibits these characteristics in this domain, so draw it for that domain. At least draw a possible thing that it might look like, okay? So you've got lots of options, right? Take a seat. Like, this is very, very broad, okay? So we just need to make sure it ticks all the boxes for these, and then you can draw whatever you like that fits there, okay? All right, so let's start from the top. So f is greater than 0. Okay, now just visually, what does that mean? That's right. So if it's positive, right? It's that's what I was looking for. It's above the axis. Okay, so that means, say again. Yeah, sure. Yeah, we'll get there. Okay. So that's where it is. That's where it is. Now, how's it behaving? This is the first derivative, right? So it's less than 0, meaning what kind of function is it? It's decreasing, right? So it's going to go from high to low. Okay, one last quality about it. Second derivative is greater than 0. So this describes not gradient, but concavity, and it's concave up. Okay, so all right, so decreasing is it's kind of going down, right? If it's concave up, that means it's facing like this, right? Concave up like a cup, right? Concave down like a, yeah, you remember this, okay. So, yeah, that's right. So I also need to have the position, so let's draw actually a set of axes. Okay. Now it begins at A and it ends at B. I don't think they tell us anything about A or B, right? So I'm just going to put them both over here. So here's A, here's B. Okay. I've got to make sure I stay above the axis, and I've got to go from a higher point to a lower point. Yeah? So that's taking care of the positive, it's above. It's taking care of decreasing because it's going down. Now the concave up part, you just have to make sure it has that kind of curvature to it. That's it. Okay. So what if we change some things? What if suppose, let's get rid of this. What if suppose I changed it this? Let's make that positive, okay? So what's that going to mean now? What's it going to look like? How will it be different? It's still going to be concave up like a curve, right? But it's going up like that. Okay. Let's change it again. Suppose I said, let's get rid of this. Suppose I said that the second derivative is equal to 0. What does that mean?
It is straight. It's a straight line. It has no concavity.
Ah, okay. So,
but that cannot be possible. Oh no, yes it can because it has a limit. But if it did not, if it was
well,
all real,
it could. Alright, so the first thing I want to catch, which is helpful, is you think, oh, normally we think of this as point of inflection, like possible points of inflection, right? That's a good thing to think, but the reason why it's not actually what we have here is because this property is true over an interval, not just at a single spot. Okay, so therefore what you have to have is a straight line. Okay, it doesn't have concavity. It's not concave up. It's not going to catch water, or water's not going to flow down it, right? It's just flat. And if you think about, you know, what kind of function might this be? This is kind of like your mx plus b kind of situation, right? So it's just a linear function. When you differentiate once, you get m because the constant drops off, and then when you differentiate a second time, you get 0. There's the concavity being 0. Okay. So really, just make sure you go through them one by one, tick off all the properties, and you'll be fine. Yeah. Oh, you mean for this? Okay. Well, okay. If we said this, what might that mean? In some ways, I could leave it as is right now. That would be fine. Okay. If you have a concavity of 0, right, that means your gradient isn't changing. Right? This tells you how this is changing, and this tells you how this is changing. So whatever you've got, it's still got to be linear. There can't be any change. Okay. Now on the other hand, if I said this, okay, so now this is concave down. This means it's increasing or what? Or stationary, right?
But it cannot be.
Okay. So now, if I'm increasing or stationary, and I'm concave down, I could have this kind of situation. That'd be fine. Yeah, it could be stationary there. That's about it. But it doesn't change all that much. I mean, I could have done the previous one, not have a stationary point there. Let's make it a bit higher. just curved. There's no stationary point there. The first derivative is never actually equal to 0 there, but it still obeys the properties that we've been given. Oh, that's fine.